Now let's analyze another important system register, that is FAREL1 register. This register is important for debugging purpose, so we need to analyze it in more detail. First, let's look at ARM reference manual that describes the definition of FAREL1 register. What is FAREL1 register? It means fault address register. As the name of this system register implies, it holds the faulting virtual address. The faulting virtual address means the invalid virtual address. So for example, 0x4, 0x0 could be one of the examples for the invalid address or faulting address. The usually faulting virtual address can be accessed when the LDR or STR instruction runs, because those two instructions are usually executed to access the virtual memory. So this register holds the faulting virtual address for synchronous instruction or data abort, or exception from the misaligned PC, or watch point debug event. But that is taken to exception level 1. But this means that if the exception is only taken to exception level 1, then this register is updated. In other words, if the exception is taken to exception level 2, the FAREL2 is updated in this case, instead of FAREL1 register. So this has important meaning. So FAREL1 register is most checked during debugging when you go through the memory abort. So it is very important system register for debugging purpose. So now that you got to know about the FAREL1 register, let's look at example assembly instruction to read the value of FAREL1 register. Please look at this. Just like the system register, MRS instruction is used. In this case, the value of FAREL1 register is written to X4 register. As you know, X4 register is one of the general purpose register in Armv8-A architecture. Remember that this register, FAREL1 register, is updated inside ARM core when exception happens. So usually, software does not write the value onto FAREL1 register. In most cases, the system software engineer like us, we check the value of FAREL1 register to find out the invalid address or faulty address. When the system software engineer go through the crash issues, many of them inspect memory dump to identify the faulty address, because many of the crash issues is generated due to invalid memory access when running LDR or STR assembly instruction. But since this register lets us know the invalid address or faulty address when the memory access happens, so this register is extremely important. Now let's look at when this register is updated. Just like ERR-ER1 registers, this register, FAREL1 register, is updated during the generation of exception. Just like ERR-ER1 register, this register is updated at the microarchitecture level when ARM core generate exception. The workflow of how the exception is generated is identical, is already explained in the previous lecture. So I just skipped this operation. Right after the exception is taken to exception level 1 by moving to exception handler, so as in the first step, software will read the value of FAREL1 register to identify the faulting virtual address or faulting invalid virtual address. So by reading this value at the corresponding exception handler, it will determine some other operation. In many cases, it terminates user process if the exception occurs in the user space, or it may reset entire system if the exception occurs in the kernel space. That is the typical scenario of the exception handler in Linux, the kernel. Now moving back to the main topic, FAREL1 register means fault address register. This register holds the faulting virtual address, faulting invalid address. So every time you wanted to inspect memory dump to troubleshoot into crash issues, so looking at this register is extremely important. So now that you understand how FAREL1 register works, in the next lecture, we're going to explore another important system register for exception handling. That is ESREL1 register.